Exercise 6D, question 1. We want to simplify each of the following expressions. If we're going to start with the first one, 1 plus tan squared of a half theta, it's going to be sec squared of half theta, because the angle is half theta. If we're going to look at the first one for part B, sec theta minus 1, sec theta plus 1, we use the difference of two square numbers. This is going to give us a sec squared of theta minus 1. So if I'm going to rearrange the second one, if I rearrange, I have tan squared of x, because is in terms of x. My identity here, tan squared of x, is therefore sec squared of x minus 1. This is equivalent to the rearranged form. So I can therefore rewrite sec squared of theta as the equivalent to this must be tan squared of theta. If we do part C, we would like to start from cosec squared of theta minus 1. If I'm going to start to replace in here cosec squared of theta with our identity that we know, we start with tan squared of theta. We do nothing to this. I'm going to replace cosec squared by 1 plus cot squared of theta minus 1. Here, this is going to cancel down. We have tan squared of theta multiplied by cot. Cot could be, I could write it down as 1 over tan squared of theta. Now this is going to cancel down, will be equal to 1. If we want to rewrite sec squared of theta minus 1, we can rewrite with the rearranged form. So we want sec squared of theta minus 1 to replace that by tan squared of theta. Tan squared of theta we have multiplied by cot theta. Cot we can rewrite it as 1 over tan, so we have tan squared of theta multiplied by 1 over tan theta. We can simplify, will leave us now with tan theta in here. If I'm going to copy down E, we want E now. For E we have cosec squared of theta minus cot squared of theta, everything squared for E. So I could start to rewrite in this case as cosec squared. If I rewrite cosec squared with 1 plus cot squared, so 1 plus cot squared of theta minus cot squared of theta, everything squared. Now I can cancel this down, will be 1 squared as equal to 1. E, we can do F. F is 2 minus tan squared of theta add sec squared of theta. Sec squared of theta we can replace by 1 plus tan squared. So if I will have now 2 minus tan squared of theta, we replace sec by 1 plus tan squared of theta. Now this is going to cancel down, will give us as equal to 3. E, F, G. is tan theta sec theta divided everything by 1 plus tan squared of theta. So I can therefore replace 1 plus tan squared of theta by sec squared of theta. So I have tan theta sec theta over sec squared of theta, which now we can cancel down. We have tan theta over sec theta. So sec theta, I can write this down as tan theta sec theta. I can write it down 1 over sec is cos theta in here. So as well, tan theta, I can write as sine theta over cos theta times by cos theta over 1, which this now can be cancelled down, would leave us with now with sine theta in here. H, if we do H, we have 1 minus sine squared of theta multiplied by 1 plus tan squared of theta. So 1 minus sine squared of theta, I know is cos squared of theta, multiplied by 1 plus tan squared of theta is sec squared of theta. So as well, this is sec squared of theta in here. So I will do nothing to cos squared of theta, but sec squared, I can rewrite it as 1 over cos squared of theta. Now these, they could be cancelled down and is equal to 1. H, I cosec theta cot theta, and 1 over cot squared. 1 plus cot squared of theta. Now, cosec squared and cot. 1 plus cot squared is cosec squared. So I will do nothing to our numerator, but 1 plus cot squared. This, I can replace this by cosec squared. So this will become cosec squared of theta. So we have our numerator is cosec theta cot theta, which now these, they can be cancelled down, would leave us with cot theta over cosec theta now here. Now we can write cosec, and I could split this 1 over cosec theta times by cot theta, which I can cot theta over 1. Now, 1 over cosec is going to be then, therefore, this 1 over cosec, I know this is sine theta. I could write the sine theta over 1. Cot, I could write it down as cos theta over sine theta, which now these could be simplified, would leave us with cos theta for the answer. I, J, and Okay, let's see J. For part J we have in here, right, J. If I copy this down, it's going to be sec to the power of 4 theta minus 2 sec squared of theta tan squared of theta plus tan to the power of 4 theta in here. Now, I can factorize this if I would know this is now what I should be able to recognize. This is a minus b, everything squared is a squared plus a squared minus 2ab plus b squared. So if I do recognize that this is going to be now sec squared of theta minus tan squared of theta, everything squared. And if I do recognize this, this is J, I can start to rewrite sec squared of theta. I want to rewrite sec squared of theta into 1 plus tan squared of theta. So I replace 1 plus tan squared of theta minus tan squared of theta. Now everything squared. Now this could be cancelled down, would be equal, everything would be equal to 1 in here. And the very last one, it will be similar.